Okay, this is our video for section 7.1, Law of Sines, day 2. In this lesson, we're going to talk about the special case of law of sines, which is the ambiguous case. On the right, in this first slide, you can see a little snippet of our cosine graph. We are only looking at the cosine graph between 0 and 180 degrees in this picture because those are the only angles that are possible in our triangle situations. Usually we're used to seeing this in radians, so instead of 180, you can think of this like pi. At 0, our cosine is 1. At 180, our cosine is -1. And at 90, it's 0, and that's where this graph is coming from. If we're solving an equation, cosine theta equals k, and k is some number between -1 and 1, we find k, let's say it's a positive value on our graph, and if we were solving it graphically, we would make a horizontal line at k, and wherever we saw that intersection at, that degree measure or radian measure would be our solution for theta. And you can see no matter where I draw a line for k on my cosine graph, there's only ever going to be one place where we intersect the cosine graph, and therefore only one solution ever to cosine theta equals k, where k is between -1 and 1. The sine graph is going to look a little bit different. So here's a picture of the sine graph in that same range of values from 0 to 180 degrees. And again, let's think about that same situation. We're solving sine of theta equals k, where k is a number between -1 and 1. Here, it's only going to be possible to solve where k is actually a positive number. And if k is a positive number, and we try to solve, we're looking for an intersection, and we get two intersections. One will be an acute angle between 0 and 90, and the other will be an obtuse triangle. So it is possible that we're going to get two different solutions for theta, and therefore potentially, depending on what values we already have in our triangle, two different triangles completely based on our given information. It is also possible that if k is a negative number, you can see there's no intersection there between 0 and 180, that we would have no solution and therefore no triangle possible. So we don't have to worry about this with cosine, only with sine. So only with law of sines is this going to be an issue. And again, depending on what k is and what numbers we already have, we could, based on any given situation, have 0, 1, or 2 possible triangles. Those 0, 1, or 2 possible triangles won't always be something we have to worry about. It's actually only going to happen when we have the side-side angle condition. So I remember that it spells a bad word backwards. So maybe that's a way that you can remember the special case. And it also, if you don't remember side-side angle, is a way to think about it. Also another way to think about it is that you're solving for an angle in the law of sines. Whenever you solve for the angle in the law of sines, that's when our 0, 1, or 2 possibilities could pop up. All right, so we're going to go ahead and start with our first triangle and just kind of see how these resolve themselves as we're solving. Here we're just given values. So I'm going to label a triangle ABC. This is just a generic triangle. There's nothing special about it. Angle A is 40 degrees. Side A we must know to be opposite angle A, so 23. Side B, opposite angle B, is 20. And here we are solving the triangle. It does tell us it's side-side angle, but you can also see that in the picture as we rotate around the triangle. Side, side, angle is my given information. All right, solving using the law of sines. First thing I'm going to have to do is find two opposite pairs. So 40, of course, and 23 are an opposite pair. 20 is the only other piece of information I have, and it's opposite angle B. So that's actually going to be the first thing I solve for in this triangle is angle B. Setting up my law of sines, so this is just review from yesterday. Sine of my angle B over 20. Sine of 40 degrees over 23. So at this point, you can see we're using law of sines to solve for an angle. So if you haven't realized you're in the special case yet, you can see it when you're setting up the problem. Cross multiply. 23 sine B equals 20 sine 40. We're going to divide by 23 on both sides, and you can do that part all in your calculator now. Make sure, again, you are in degree mode. You should still be in that mode from yesterday. 20 sine 40 divided by 23 I'm going to get 0.56. And now at this point, because 0.56 is not something that's on our unit circle, not something we're going to get an exact value for, we're going to use our inverse function to solve. Inverse, inverse on both sides. So b is equal to whatever the inverse sine of 0.56 is. And the calculator, if you remember where inverse sine is defined at, it's defined in quadrants 1 and 4. The calculator is always going to spit out an answer in quadrant 1. So 34, I'll just round to the nearest degree, 34 degrees in this case. Now remember I said, if you think back to that picture on the previous page, there's always an acute angle. This guy, that's the one we just got. There's also an obtuse angle that we're going to have to find. That is the one the calculator is not going to give us. The other potential answer can be found using what's called, it's written at the top here, the supplements theorem. The supplements theorem says that sine of an angle is the same as sine of its supplement, 180 minus that angle. So if I want to apply that property to this right here, it tells me my other potential angle for B is its supplement, 180 minus it, which in this case would be 146 degrees. Okay, so angle B could be 34. 34 seems like a reasonable angle. 146, though, we're going to have a problem with. If I put 146 into this triangle, hopefully you see that we're going to have an issue with these angles. I have more than 180 degrees, which means although mathematically 146 would work in the equation we've set up, when we want to relate that to real life, this triangle, it is not a reasonable solution. So what does this all tell us? We were able to solve for one answer that makes sense, 34 degrees, and I'm going to go ahead and put that in my triangle now. And the second potential answer we got didn't work. So this all comes down to there is only one triangle possible in this situation. And we have it drawn, so we can go ahead and finish the problem. Next thing I'm going to do is 180. Take away the two angles I know, which is going to give me 106 degrees. And then finally I have to solve for side C, which is opposite angle C, which is going to be one more law of sines. So that will be sine 106 over side C equals sine, I'm going to use my given information, 40 over 23. And then from there you can cross multiply. You're going to end up doing 23 sine 106 and then dividing it by sine 40. And that's going to give me, I'll just round to the nearest tenth for the side length here. It looks like 34.4. So that should solve the triangle. We have angle B, side C, and angle C was in our triangle there we drew, and that will solve it for us. Again, a nice easy way to check that what you've drawn is reasonable is remember the lowest angle should be across from the shortest side. The highest angle should be across from the longest side. Okay, let's try another one. Solve the side-side angle triangle. Again, I'm just going to draw a generic triangle here. All my triangles are going to look the same, nothing too fancy. Just remember these are not drawn to scale. Angle B, 97 degrees. Side B, 27. Side C is 30. All right, solving the triangle. I have one pair of opposites. 30 is my only other piece of information. It's across from angle C, so that's going to make up my second pair, and that's what I'm going to have to solve for first, angle C. So sine of capital C over 30, sine of 97 over 27. Cross multiply, 27 sine C equals 30 sine 97. Divide by 27. So 30 sine 97 divided by 27 gives me 1.1 about. And then we're going to do inverse sine. Inverse sine. C equals, and if I do inverse sine in my calculator, it tells me error. And hopefully you're getting the same. Maybe even your red flags went up a minute ago. with this 1.1. We know that sine of an angle can never equal anything larger than 1 or smaller than -1. And the calculator is telling us that when it says error, you should see domain error on your calculator screen. So what does this tell us? It pretty much tells us with the given information, it is impossible to draw this triangle. Although it looks like it's possible here, that angle B is too large and my side AC is too short for these sides ultimately to match up if you were going to get out your protractor and your ruler and try to draw this to scale. So we're just going to say no triangles possible, and therefore there is no solution. Okay. All right, we're going to do one more example in this video. Same sort of situation here. Solve the side-side angle triangle. Draw a rough sketch here of just positions of things. A, B, C. Angle B, 32. Side B is across from it, 50. Side C across from angle C, 60. You can see this is the same amount of given information, same angles and sides even that we were given in the last problem. B is opposite B, C is opposite C, and those are my two pairs to make my law of sines problem. So sine of C over 60, sine of 32 over 50. Cross multiply, 50 sine C, 60 sine 32. I'm going to divide by 50, and we should get a number between -1 and 1, hopefully here, something that's solvable. So 60 sine 32 divided by 50, I get about 0.64. Of course, you don't have to round that in your calculator. In the next step, we're going to do inverse sine of our previous answer. And I'm going to get C, I'm just going to round to the nearest degree. It's 39.48, so I'm going to round to 39 degrees. Okay, so we do have a solution, which means there is at least one triangle possible. I'm going to put that 39 here. It is possible that you could have a second triangle. To get that second possibility for angle C, we're going to do 180 minus the angle we just found. Its supplement is what we're calculating. And that's going to give us 141 degrees. I'm going to draw my given information again one more time. 32, 50, 60. So now we want to ask ourselves that other angle C, 141 degrees, is that possible in this triangle? Well, 141 plus 32 gives me 173 degrees, which leaves me some degree measure left for angle A. If that's possible, then this is our two triangle situation. I've already drawn the second one. Over here I can solve for angle A the same way, 180, take away the 2 I have, 109. And now because I have two triangles, I have to solve both triangles. So let's say I want to solve for side A here. A is opposite 109. That's a law of sines. It would look like sine 109 over A. And I'll use the given information. Sine 32 over 50. If I wanted to solve for side A in this triangle, it's opposite 7. And again, I'll probably use 32 and 50 because those are my given pieces of information. Sine 32 over 50 equals sine 7 over A. In both cases, we're going to cross multiply to solve. So in the first one, I'll do 50 sine 109 divided by sine 32, 89.2, which in that first triangle, 109 is the largest angle, so we should expect that the side opposite it, 89.2, is the longest side, and that makes sense. Looking at the second one, 50 sine 7, if I'm cross multiplying, and then I'll have to divide by sine 32. I'm going to get A equals about 11.5, it looks like. And in this triangle, side A should be the shortest, which it is because it's opposite the smallest side, or smallest angle, excuse me. So we have two triangles that are possible. Remember, these pictures are not drawn to scale in any way. The one on the right, especially, 7 degrees is a very tiny angle. 141 is a very large angle. So these are very different triangles from what you actually see in this picture. The pictures should only really be used to look at the reasonableness, if that's a word, of your answers. Again, smallest angle, shortest side, longest angle, longest side, largest angle, opposite one another. If a problem on Math Excel asks you how many triangles are possible, there are some formulas that can be used in your textbook if you're interested in looking at it. It has to do with doing some multiplication and comparing some inequalities with the side lengths and the angles that you're given. I think it's probably more work than it's worth, but if you like using formulas, you can check those out. Otherwise, I would just start solving the problem like we've done, and as soon as you solve for that first angle, it's going to reveal itself. If only one of the answers works, you only have one triangle, and you could stop there and answer the question. If both answers work, you have two triangles. You can stop there and answer the question. And if you do your inverse sign and you get an error message, that means no triangles are possible. You can stop there. But again, if you want to check out in your textbook in section 7.1, there's a nice little chart that talks about A's, B's, and C's, and there's some inequalities to show you based on how they compare to one another, how many triangles are possibly going to be drawn. So just remember, ambiguous case, this is only going to happen in our side-side angle condition, or if you are just looking at the law of sines, if you forget that piece, it's when you're solving for an angle in the law of sines that you have to worry about this. Everything we did in the lesson yesterday is just one case, one triangle only. All right, that is the end of 7.1 day 2. You have a Math Excel assignment. That is also due on Wednesday, the 17th, 11:59. Tomorrow, come to class with any questions you have over this lesson. We'll start by going through those, review a problem if you need to, and then the rest of the period will be used to work on your Math Excel in class. Thanks, guys.